In this tutorial I show you how you can use a solar and long-wave environmental irradiance geometry model, or easily Solweig, to estimate the mean radiant temperature in QGIS. Solweig is a model that simulates spatial radiation of 3D radiation flux in the Tmrt in complex urban setting. So, for use that tool, for the first time you have to open QGIS and install the UMAP plugin. After you have installed the plugin, you can find it in the item bar. In this UMAP tool plugin, you will find a series of secondary tools that are necessary for run the simulation. We will start from a preprocessor tool called DSM generator. DSM mean digital surface model, so represent the surface, the height, and the building, and all the surface that compose a certain your urban area. For instance, you need a raster file of the digital elevation model or digital terrain model, and a vector file of the building with information about the height of the building. In the panel, you have a digital elevation model for input, DTM for input, a polygon with building that it's a shapefile with information about the height of building. You have to very important things, and to select the same extent of the layer of DTM, and select a output folder for save the output file, that is our DSM. In this tutorial I have used a very small area for a faster simulation. This area is, I show you that is georeferenced, and it's located in Randers in Denmark. In this case, this area it's about 100 square meter, but you can simulate greater area, about 1 kilometer, 5 kilometers or more, but it depends of your computer and your processor. So this is our DSM output from 5 meters to 28. That is this building in white. And continue with the preprocessor. We have to do the tree generator. The model needs to generate the trees to compute the heatwave impact. For the trees, you need a point shape file that have to simple parameter that is tree type. Tree type is or conifer or deciduous trees, but is not very important. It's 1 or 2. Total height, it's the height, the trunk zone, the trunk, and the diameter of canopies. So you have to realize a shape like that with the point that represents the trees, and the field of the type. I put here 2, that is conifer. Yes. Okay. And height, I put 7 meters, and canopy diameter. Canopy diameter, that's 5 meters, and also the trunk zone. Meters. Okay. This is the table, attribute table, in this way. Clearly, when you know the trees, the species, the height, more information, you have to improve this. This is, for example. So we return to tree generator in UMAP reprocessor spatial data tree generator. Select the field that to improve trunk zone and diameter. It's okay. DSM exist is here. Select the output folder and the name of the output file. Okay, now we have the DSM of the vegetation. And I put in the GIS. The DSM is for the canopy, and the TDSM is for the trunk. T and C. It's not very different. Now we have to make the scale factor with the DSM. We have also the vegetation DSM, trunk zone exists, and select this one. Vegetation canopy is C and trunk is T. Output always the same, and run add results to project. Now we have the scale factor. We have to make also the wall height and aspect, also with the DSM. Aspect and wall height. Result to project and run. Okay. Now we have all the pieces. You have to, you can also implement another layer of information that is the land cover. With for this, you need a raster that represents the land cover classification. For my case, I will skip this step because the area is very teeny and it's all paved area. So I don't need this information, but you will improve this information about land cover classification if you have a raster that represent the urban land cover. Now we have completed the preprocessor phase, so we can pass to the simulation phase. For simulation phase, you need all the file that we have produced in preprocessor file, and in addition, you need information about the climate, so meteorological data. How we can do the simulation, the mean radiant temperature is this, the processor out of thermal comfort Solweig. I'll show you. Okay. In this folder, you have to improve all the preprocessing layer that we have done. So we select the building and ground DSM, is this scale factor that we are calculate here, the folder. You want the folder, the zip. Okay. Use also the vegetation scheme that we have calculate for canopy and for trunk. That is here. Okay, here you have to calibrate the transmissivity of the vegetation. For example, we have there is also the guidelines that we. Okay, this is a new land cover scheme. We don't use in this case, but you have to use also the DTM, all aspect raster and height that represent the height of the building and the aspect. And okay, here we need meteorological data. You can use a data set. The data set describe a certain day or more days that if you need this information about the temperature, the pressure of the air, the relative humidity, wind speed, and so on. Or you can select manually the parameter of a certain day that you have decided, and run a simulation of for 1 day. Where now that we have filled all the parameters, all the input of that Solweig required, select even output folder for save our raster file simulation. Save in the same folder, and we can run the simulation. Solweig say us that the simulation has successfully, and this is our results. This is the raster output file that describes the Tmrt of our